All right, since there's no lesson notes, let's look at the examples. In 1840, the population of Florida was about 54,500. Over the next 20 years, the population grew exponentially, increasing by 60% per decade. Use the exponential growth / decay formula to answer the following questions. Number 1, find the population of Florida in 1850. So our initial value, when we plug in, our initial value is going to be 54,500 times. Our growth rate is 60% per decade. So our growth rate, our growth factor, is going to be 1 plus 60%. So my growth factor is going to be 1.6. And then what number am I going to plug in for X if the population is growing 60% each decade? So 1850 is 1 decade later. It's 10 years later. 10 years is 1 decade. So what I'm actually going to plug in, I'm actually going to plug in 1 for X because my growth factor is per decade. So 1850 is 10 years later, which is 1 decade. 10 divided by 10 is 1 decade. So I'm going to plug in 1 as my exponent. So I'm going to calculate 54,500 times 1.6 to the power of 1. And we get an answer of 87,200. Okay. Number 2, find the population of Florida in 1860. So we're going to do the same thing we did here. Okay, so 54,500 is still my initial value. 1.6 is still my growth factor. The only thing I'm going to do is change the exponent. Okay, 1860 is 20 years later. 20 years is 2 decades. 20 divided by 10 is 2 decades. So I'm going to replace the 1 with a 2. That is literally the only thing I'm going to do. Replace the 1 with 2. And there's my answer of 139,520. Okay. For number 3, write an equation for a function p which models the state population X decades after 1840. So my equation, okay, right, an equation P. So I'm going to use P equals instead of Y equals. P for population. Okay, my initial value is still 54,500. Okay, the only thing that's going to change is that X value. Okay, and the important thing to realize here is that X is decades. The X value here represents decades, not years, because it's growing per decade. So this right here is the equation for number 3, 54,500 times 1.6 to the power of X. Find the population of Florida in 1855. So 1855, okay, let's set up the formula here. The same initial value, same growth factor. 1855 is 15 years after 1840. Now remember, we said our X value needs to be decades. So 15 years is how many decades? Well, I'm going to divide that by 10. 15 divided by 10. Okay. 15 divided by 10 is 1.5 decades, a decade and a half. So I'm actually going to make my exponent 1.5 because 15 years is 1.5 decades. So I'm going to make this exponent a 1.5. And we get, I'm going to round to the nearest whole number here. We get 110,300. 110,300. That is the population of Florida 15 years later. Find the population of Florida in 1858. So 1858 now is going to be 18 years after 1840. 1858 is 18 years after 1840. So I need to convert that by decades by dividing it by 10. So 18 years is 1.8 decades. So when I plug into the formula, I'm going to replace 1.5 with 1.8. 18 years is 1.8 decades. So I'm going to change this exponent to 1.8. We get a population of 127,003. 127,003. Around the nearest whole number. Okay. So that is the answer to number 5. Number 6, find the population of Florida in 1861. 1861 is how many years later? 1861 is 21 years later. So 21 years is how many decades? Well, I'm going to divide that by 10. 21 years is 2.1 decades. So when I plug into the formula, I'm going to replace 1.8 with 2.1. 21 years is 2.1 decades. So essentially, I'm going to replace that exponent. 2.1. We get a population of 146,234. So that is the population of Florida in 1861.